Happiness is understanding physics. Wow. We're dealing with circular motion or rotational motion questions. And in this video, we are going to write the question on the screen that you're able to see. Yeah. And by the way, if you have not yet subscribed to this channel, kindly subscribe. And also, you can be my ambassador. In as much as you are enjoying my videos, you can be my ambassador, whereby you are also sharing with your friends so that they are also enjoying our content, because I know you do enjoy. So share with your friends as well. All right. A person is held stationary in a rotating drum against the wall by the static friction force exerted on him by the wall as shown. All right, so we have a bit of a diagram there. Find the required coefficient of static friction between the man and the surface of the drum to keep him from slipping down. All right, the radius of the drum is 2.5 meter and it is rotating at 0.6 revolution per second. Okay, so how do we get started looking at that problem? Number one, the first thing that we have is to have a mental picture. All right, we have a mental picture about it. We must be able to see a situation. We must be able to see a scenario away from the screen. You have to see it there, a mental picture. All right, you have to see it. Okay, this is the situation. It is spinning, and this is a man who is spinning in a drum and all that. How will be the forces? You'll be able to see the forces. Because in physics, if you can't see it, it's difficult to solve it. All right, so what I can see myself, I can see something like this. If I say this is a man here, right? Is on the, of course, on the end of the drum. Now, the first thing that I see here is that I need to make an assumption that the radius of the drum is equal to the radius the man is from the center of the drum. You get it? All right, of which I know it's difficult, or the person has to be very thin and all that, which is not true, let's say. But for the sake of the question, we are going to assume that the radius of or the distance that the man is from the center here, where the man is the same as that. So that is the assumption that we are going to make. So the radius of the drum is equivalent to the distance the man is from the center of the drum. Are you getting it? I know you may say the man may be fat and all that, of which I know, even myself, I have some, some steaks that, okay, has to be put into consideration. But for the sake of this problem, so what we're going to say is this. This man is going to have the weight, which is mg, all right? This is a man here, that's what I've said. And then we are saying that the friction force is keeping this man from going down. So if the friction force is keeping the man from going down, it means it's there, because the friction force is the opposing force. So it means up here, we have the friction force. And then, now we have that, then here we are going to have the normal force. And you can see that the normal force is acting as a centripetal force here. Remember, no, I think that was in class, I think, a physical class, where I was telling students to say the centripetal force, it can be any force as long as it's pointing towards the center. Yeah. So the normal force is in that direction. So now, looking at that, we need to come up with something here. So we start with the Newton's laws. So we can start with the y, and this person is not rotating in the y. So we have 0 there, where we have the friction force minus the weight giving us 0, and the friction force is equal to the weight. So that is our first equation. And then from there, we also know that summation of forces in the x, they are giving us the revolution, and this forces in the x is the centripetal force, and the motion is the circular motion which is giving. So we have the centripetal acceleration there. Now, what is the centripetal force? The centripetal force is the normal force in this case, which is equal to m. And what is the centripetal acceleration? Is v squared over r, radius. All right. So we have that as our second equation. Now, one other thing that we know is that there is a relationship between the centripetal force and the, between the normal force and the friction force. And the relationship goes like this. Friction force is given by the constant or the coefficient of friction times the normal force. So that here we can say, if we want, we can say this is our equation 3, and we get equation 2 into 3. What are we going to have? So 2 into 3, we are going to have friction force being equal to that mv squared over r. Let that be our equation 4. So it's just playing with equations. Okay, so let me just put small data here. The radius is 2.5 meters, and omega is 0.6 rev a second. What else? Nothing. Okay. All right. So now, what do I have? I have also my equation 1. So you can see that equation 1 is equal to equation 4. So what we're going to have is the right side of equation 4 being equal to the right side of equation 1. All right. So now, also what you can see as well is that the angular speed we've been given is in rev per second, or it's the angular speed, but here we have the tangential speed. So you can you can do what you want, but here we can convert. We know that v equal to r omega. So substituting there, we are going to have nu r squared omega squared over r being equal to mg. Right. So we're going to have that over r mg. So r and r goes, m here and the m there goes, which let me use here. Let me use this part. What do we have? We have omega r omega squared being equal to g. So I divide both sides by that. So that what I'm going to have is that. So now, let me convert, because I know that gravitational acceleration is in meter per square second and R is in meters. So I need to convert this in rad per second. So how is it going to be? Okay, let me convert it from here. Sorry. So I'll convert it from here. So 0.6 rev per second equal to 2 pi rad per 1 rev. So that and that goes. So what I'm going to have is isn't 1.2 pi rad per second. Let me just so I can substitute 9.8 meter per square second over a radius 2.5 meters and 1.2 pi rad per second. This is squared there. So what I have is 0.2758, which it can be 0.28. So that is a coefficient of static friction, keeping this man from sliding downwards. All right, so that is how you get to solve that question. So thank you so very much for your time. Remember to subscribe to the channel